Hi, I'm John Paul Raj, and in this video, we will solve question number 1 from paper 3, May 2025, time zone 3 for IB Math applications and interpretations. Let's get going. This question considers how the assessment of the air quality index AQI for a school depends on the method chosen by the person doing the assessing. Okay. Air quality for a district is measured at 3 monitoring stations. The positions of these stations on a coordinate system with units in kilometers are A, B, and C. A is here, that's one of the station. B is another station. C is another station monitoring this air quality. And what do we have? A Voronoi diagram is constructed with the 3 stations as sites. So they are the 3 sites there. Question number A, part 1. Find the equation of the perpendicular bisector of BC. BC, if you look at the coordinates of BC suggest that the x coordinates of both B and C are the same, 8. Okay, which means that if you were to draw a line joining B and C, it's actually a vertical line. Okay, vertical line. So the equation should be x is equal to 8. That's the equation of BC. What do we want is the equation of the perpendicular bisector of EC. Perpendicular bisector of BC is this line, this line that we have here. Okay, it passes to the midpoint, and because it's horizontal, x is equal to 8 is vertical. Because this is horizontal, it'll just have the line of the form. The equation will be of the form y is equal to k, which is basically the y coordinate of the midpoint of B and C. So let's just find the midpoint, I think, and then whatever that y coordinate of the midpoint is, that would be the equation of the perpendicular bisector of BC. Hope I explained it clearly, and hope you understand why we are finding the midpoint. Okay, let's just find the midpoint first. Okay, so let's just do this question here. This is 1a, part 1, and we can write on midpoint of BC, and with the coordinates given to us, we can just write down this is 8 plus 8, that's just 8, and this is going to be 9 plus 1 divided by 2. Okay, so with the coordinates that's given to us, 8, 9 and 8, 1, those are the coordinates of the midpoint of BC, and this is clearly 8, and this should be 5. All right, so this is what I said, the y coordinate of the midpoint should be, so this is your 8, 5. And so this should be basically 5, the equation of the perpendicular. Okay, once you show that, you can write down, since the perpendicular bisector of BC is a horizontal line. And in your exam, you can actually sketch that, okay? You can sketch that, okay? Why is it good? You can show that because that's part of the working. Horizontal line passing through the midpoint 8, 5 equation. Its equation is y is equal to 5. That's it. That's about it. Okay, this is A part 1. What's A part 2? Given that the equation of the perpendicular bisector of AB is 15 minus 2x, AB. Now let me just erase this part. Okay, annotations. I'm just going to erase it. If you've missed it, please go back, rewind and watch. Okay, so this is the AB we're looking at. Perpendicular bisector is this one. Okay, for AB. Given that the equation of the perpendicular bisector of AB is this one, so 15 minus 2x, okay, is the equation of this line. All right, this line. Let's just mark that in red. That's the perpendicular bisector of AC. Find the coordinates of V. Find the coordinates of V. Now, V is the point of intersection. V is the point of intersection of this red line and the line that we just found off, y is equal to V. So, y is equal to 5, sorry. So, because it's the point of intersection, it will satisfy. So, basically, how we're going to do this is we're just going to equate the two. We're just going to equate y equals to 5, the equation of the perpendicular bisector of BC, which we found just about 1 or 2 minutes ago. All right, this is y is equal to this one, sorry, this one. This one is y is equal to 5. Okay, so it's the point of intersection, as you can see. That's the point of intersection. So point of intersection of y equal to 5, that horizontal line, and 15 minus 2x is what we want to find out. Okay, so let's just explain that in the answer before we find. Okay, we'll just mention that it's the point of intersection. So A part 2 part 2, you say coordinates of V equals point of intersection of y is equal to 5 and what's that? Y equals 15 minus 2x and y equals 15 minus 2x. Clearly explaining, the reason. Clearly explaining the reason what you're doing and why you're doing. So you can just say then y 5 is equal to 15 minus 2x, and then you can find the value of y, find the value of x as it is, 2x. You can do it algebraically, or if you want at this point in time, you can use a calculator. I'll just do it algebraically. X must be 5, and corresponding value for y is 5, as you can see. Okay, so the coordinates of v has coordinates 5, 5. All right, we already started with y equals 5, so it's obvious that the y coordinate must be 5, and we also know that v lies on this line also, right? So where y is equal to 5, so the coordinates of v are 5, 5. Clear? Too many annotations, that's why I keep erasing it every now and then. So if you have to go back and check, as I said, pause the video, rewind it and check. That completes part A. Let's look at the information before part B. A school S is situated in the district at the point with coordinates 5, 6. So there's a school that's situated with coordinates 5, 6. State which station is closest to the school. You just have to state, there's no reasoning, and it's just 1 point. You guys can see this, right? Okay, it's just 1 point. You just have to state. So let's just 5, 6. If this is 5, 5, then along the x and 1 unit up, at least 1 unit up. So, somewhere there, let me use another color. What color can I use? Can you see this? Okay, that's where the school S is. That's where S should be. That's where the S should be. Okay, so 5, all right, 5 units from here. And obviously this is y equals 5, right? So 5, it should be just about that. And it's clear, obviously, that B, that site B is the closest. So because the school is in that cell, the cell containing the site B, all right, this is the station. And remember, they already said that's the, that's a site. This is that cell, and because S is, in that cell, then obviously that station that's closest to the school is B. All right, so they just ask state without giving the reason. I'm just going to write the answer here. Okay, so that's your 1B. The answer to that should be station B. Just 1 point for that. Okay, just 1 point for that. Just state which station is closest without giving any reason. The principal of the school is concerned about the air quality index in the area. Air quality is measured by the air quality index in this district. Values less than 50. Now that's important. Okay, anything less than 50 are taken to indicate good air quality. So it's measuring the pollution level. So that index is above 50 or more, then it's not good. All right. So if it's good, means it has to be less than 50. How it's measured, don't ask me. I don't know how this is all measured. And anything that is measured will have a error depending on the measuring instrument. Actually, I was doing some kind of reading, but that's not for this particular video. That's for some other video. I will talk about it there. Okay. The principal contacts the local environmental agency requesting for an AQI value for her school. They tell her the mean AQI reading from the closest station to the school, the mean. As I was just saying, every instrument, you've got to find the mean because it'll give you a range of values, and every time you measure a value, there will be an error. So, which is why it's good to give the mean value. And so they have given her the mean value. Write down the type of interpolation used by the environmental agency. So basically what they've done is that they've given her from the nearest school, right? The closest school. So the type of interpolation, what we study in Voronoi diagram is the nearest neighbor interpolation. Again, it is 1 point only. So what is the type of interpolation? You can just write down interpolation. The method is nearest neighbor interpolation. Okay, so I'm just going to write that answer just close to this one. So this is 1C, nearest, what's the spelling of nearest? I just kept writing neighbor. Nearest neighbor interpolation. Okay, so what's the technique used, which is the closest site, and the closest site is B. All right, and as they've said that they've used the site or the reading from the closest station to the school. The closest station was B, okay, as we've said that. So it's the nearest neighbor interpolation. The principal obtains the mean AQI from each of the 3 stations, and you can see that, this is a record. So from station A, station B, station C, those are mean values, the mean AQI values. And then part D says, explain why the principal might not accept the air quality around the school can be classified as good. Now this is the mean value, and although there was something like 50, right? If it's less than 50, it's supposed to be good. All right. So although the mean value around B is 49, less than B, less than 49. What am I saying? Although the mean value from station B, or for the region around station B, that cell station B, around station B where the school lies, is 49, which is less than 50, and that's good, right? Although it is good, the principal is a good mathematician, or good statistician. Why is she saying, and it says that's what we need to write, why she might not accept, because this is the mean, right? Mean, as I said, it can have variation, and that is why we are looking at mean. Every time there's an average, there are always students who perform above average or below average, right? That thing is called the standard deviation, and because of that, 49 being the mean, it could mean that maybe around the school it's more than 49, and more than 49 is what, like 50, right? Closing around 50, which means according to the way they're interpreting, 50 is not good, right? So the principal is rightfully she is concerned and say, 49 might be the mean, but it could be above 50, right? Because it's the mean value, it's not the exact value, and because of variability. So how are we going to phrase this answer? Okay, and it's just 1 point. And so I'm going to write down the, let's just write it in the context, okay? Explain why the principal might not accept that the air quality around a school can be classified as green. The principal might not accept. This is using the language, using the vocabulary of the question, okay? So as far as possible, try and answer in the context, the language and the words of the question. Not accept that the air quality around the school can be classified, might not accept that the air quality around her school is good, since 49, and you can write down AQI from station B is only the mean value, suggesting that the actual value could be more than 49 also, okay? As long as you've said that and conveyed that in a proper way, it can be less, of course, but because why is she saying not good? We're just answering the fact that why it's not good. It could be more than 49 because we are looking at it's just a mean value. All right, hope that makes sense. So that's this is, what is this? Is C or D? This is, let me just, this A, B, it's just C. Oh, this is D. All right, cool. The principal decides to obtain an expected value for the AQI at the school that uses all the available information. All right, that was E. Now let's move on to the next one. The principal decides to obtain an expected value for the AQI at the school that uses all the available information. To do this, she uses an alternative method. Remember, I called her a good mathematician? That's very good, okay? The natural neighbor algorithm. This algorithm has 2 stages. The first stage is to create a new Voronoi diagram with the school as an extra site. So they've made the school the extra site. There you go. That's the new Voronoi diagram, I believe. This is shown in the following diagram with the edges of the previous diagram shown in dashed or the dotted lines. Okay, so the dotted lines are the previous edges or the previous Voronoi diagram, and this triangular thing that's come in is for the new Voronoi diagram that is made S, the school, as a new site. So now you've got 4 sites, A, B, C, and that S. Okay, all right. The second stage, So the first stage is to create that. It's already done. The second stage is to estimate the AQI value at the school. That's W by using the formula. W is equal to WA. How do you read this? AA. All right, let's just call it alpha A. All right, AA. All right, whatever. WA times alpha A plus WB times alpha B plus WC times alpha C. The whole thing divided by T. And let's just understand what this formula means. In the formula, A or alpha A is the area within the new cell that has been taken from the cell surrounding A. The area within the new cell. That means it's the area of this triangle. So this is alpha A, area of this triangle. Okay, so that, there you go. That's alpha A. The area of that triangle is from that cell containing A, which means alpha B should be this green triangle. Okay, there you go. That's the triangle, containing or from that cell B, and in the same way, alpha C should be the area of this triangle. Okay, so that's what they mean by saying alpha A. This is given as 132 in the table of mean. Wait a second, what am I read past. Okay, alpha A is the area within the new cell that has been taken from the cell surrounding A, shown in the region P. Yeah, that is what the region P was, right? Okay, and WA is a mean AQI value from site A. So WA, or the formula has WA times alpha A. So WA is the mean AQI. This is given as 132. Where's the table? Where's the table? Yeah, here you go, 132. Okay, so that's WA. Alpha A is the area of that triangle in the, okay. Similarly for the sites B and C. Okay, fine. That means alpha B is the area of the triangle and WB is the index, right? The AQ index 49, and the same way WC should be that 125. Okay, 125. All right, so what are we asking? What are they asking in part E? They're saying find the midpoint of SB. SB. All right, there's too much going on here. We have the coordinates of S, don't we? 1 second. Let me just erase my annotations. SB. We found, didn't we find? The school is situated, is given. They've given the coordinates as 5, 6, all right? And B was already given somewhere before at the question level. B is given as 8, 9. Okay, so just have to find the midpoint of SB. This is E part 1. Let's just do that here. I might have to write the E part 1. Coordinates of S is the school is 5, 6, 5, 6, and the coordinates of B, where's that? 8, 9, 8, 9, and so we can then write down. Second time they're asking midpoint within the same question. I'm surprised. Midpoint of SB, and let's use the same notation. If they've given that, that's the notation for segment, by the way. All right, that's why I said, use the vocabulary, use the notation as far as possible, okay? What's given there. So now we can write this as 5 plus 8, the whole thing divided by 2, and 6 plus 9, the whole thing divided by 2. Okay, will this be in decimals? 13 divided by 2, and this is 15 divided by 2. Can we leave it like this? Probably not, right? We need to do it in this thing. So this is basically 6.5 and 7.5. Okay, you can use your calculator if you want to, but that's what it's going to be. And yeah, I'm surprised that they asked, even though the coordinates are different, I'm surprised that they asked the same thing in the very same question. Same thing means midpoint. Okay, we are done with E part 1. Let's see E part 2. Show that the perpendicular equation of the perpendicular bisector of SB is, y is equal to 14 minus x. So we have the midpoint. We just found the midpoint. Let's find the slope. Let's find the slope between the 2 points and use the point slope form. Okay, that will be our strategy. So I'm just going to do that thing here. So actually it's the equation of the perpendicular bisector. Okay, so we need to do the negative reciprocal. Let's not forget that. Okay, perpendicular bisector. So it's not equation of SB, it's the equation of the perpendicular bisector. So let's just go one step at a time. This is E part 2. This is 1E. So 1E part 2, and we'll say slope of SB. Again, let's use that. Y2 minus Y1, and we have got the coordinates there. This is 9 minus 6 and 8 minus 5. 9 minus 6 is a 3, 8 minus 5 is a 3, and that's 1. So slope of perpendicular bisector of SB must be just -1. So you can put a therefore there. Then you can write down equation of perpendicular bisector, perpendicular bisector of SB. All right, points loop form, y minus y1. You can choose any one of them. Let's just 8 and 9. 8, 9, right? Yeah, 8, 9. No, it has to pass through the midpoint. It has to pass through the midpoint. So the midpoint is what we need to use, not, it has to pass through the midpoint. So we have to take 6.5, okay? Pardon me for that. 7.5 equals m, which is -1, x minus 6.5. Hope this is clear, okay? If it was just the equation of a line, then that's fine. You can use any point. But because it's a perpendicular bisector, it must pass to the midpoint, which we found from part 1, all right? Okay, so let's just rewrite this or rearrange this. This is y equals a -x plus 6.5 and plus 7.5. And that's 14, I believe. -x plus a 14, which is the same thing as 14 minus x. I think this was a show that kind of a question, yeah, and we've shown that is exactly the equation of the perpendicular bisector. So that's all the time that we have for this particular video. We will continue solving this question in the next video. If you found this video useful, please make sure that you like, share this video with a friend, and subscribe to my channel. There are several other videos on my YouTube channel. Do check them out. And if there's any topic, any question, any concept that you want explained, do mention that in the comments and I'll make a video for you.